Good morning. So I had a few of you ask for some examples of solving systems of linear equations by substitution, and so I figured I would just go ahead and get that out of the way for you this morning. I'm going to start at the beginning and on the first sheet, on the first page. If you're curious, this is question 1. You can see it's a relatively simple equation, right? The idea here is that we have two different equations, these two different equations, and in both of them, they're a system, right? They're a system. We're told they're a system. They're grouped together, and that means we can treat them as a whole thing, as a system. And so the piece of information we're given is that y is equal to x plus 3, and that y is also equal to 3x plus 3. Now, because both of these things over here are equal to y, right? They're both equal to y, they also have to be equal to each other. Because of that fact, because they're both equal to y and therefore both equal to each other, we could say, right, first we could say y is equal to y, but more importantly, we could say x plus 3 is equal to 3x plus 3, right? Because they're both equal to something, to y, they're therefore equal to each other. Once we have that set up, that's actually the hard part out of the way. We just have to solve this equation. I'll show you. You should know how to do this by now, but we'll do it just to be on the safe side. So there's many different ways you could handle this. I'm going to subtract x from both sides because I'm trying to get it all on one spot. Bring down our equal sign. X minus x is just 0. We're left with a 3 on the left-hand side. Over here, 3x minus x is just 2 x's. Bring down that positive 3. From there, we're going to subtract 3. Again, the goal is just to get x all by itself. And then we rewrite what we have. Well, 3 minus 3 is actually just 0. And 3 minus 3, that's also just 0. So we're left with a 2x equal to 0. That might start setting off your alarm bells. You might start thinking, I'm not sure this is actually right, but you got to stick with me. We divide this side by 2. We divide this side by 2. And we'd be left with x is equal to 0. If you don't believe me, go to your calculator and type in 0 divided by 2. You will get 0. If I have 0 something and I divide it into 2 piles, how many is going to be in each pile? Well, there's going to be 0 things in each pile. Done. Now, I'm not actually done here, right? I have solved for x, but I have not solved for y. In case you forget here, the solution to a system of linear equations is actually an ordered pair, right? An x and y value that shows us where these two different linear equations, these two lines, would intersect. So we need to solve for y. And we would do that just by taking our x value and plugging it back into our equation. It doesn't matter which one of these original equations you pick. I'm going to pick the top just because, well, it's easier, frankly. We can say, all right, well, we don't know what y is yet. We do know what x is, right? X is actually equal to 0, so we'll put 0 in there and bring the positive 3 down. Well, 0 plus 3 is 3, and y is equal to 3. That's pretty straightforward. If you don't believe me, you could grab the other equation. You could try that one too. You could put this right here. Oops, sorry. And plug in what we know. Well, y is equal to 3. X is 0 plus 3. And we're left with, well, 3 times 0 is 0 plus 3. 0 plus 3 is 3, and we see that y is equal to 3. So either way, you're going to get the same answer. And all said and done, when we've gotten to the bottom of this entire thing, we now have an x value and we have a y value. And so we're not quite done until we write that as an ordered pair. We write 0, 3, close our parentheses, box it in. That is our final answer. And just in case, just if you really need this reminder, if I graph both those equations, which I've done right here, and I look for where those two lines intersect, you see that the red line and the black line are intersecting at 0, negative 3. That is the solution to this system of linear equations. That x and y values, 0 and 3, are the only x and y values that we could plug into either of these equations and that would make them true. Right? What that means is if we took, I need some more space, where am I going to put that? All right. if I took over here on the right-hand side, y equals x plus 3, and I plugged in both of my values, right? If I said, all right, well, y is 3 and x is 0, if I plug those both in and evaluated, I would get 3 equals 3. That's a true statement. And if I plugged them into the second equation, right? The second one was y equals 3x plus 3. Plug in my actual solution. I said y is 3, x is 0. Right? This solution, this 0, negative 3, is the only solution that makes both of the equations in our system true, right? It is the only, it shows us the only place where those two lines intersect. That is the solution to a system of linear equations. All right, what I'm going to do is break this up into two different videos. This is the high level. This is giving you the full, hopefully the full understanding of what we're doing. The next video is just going to contain 2 more examples that are just a little slightly more difficult and just have 1 or 2 new tricks that you need to know.